All right, folks, we are going to get the second half of section 5 and chapter 2 done today. And that's going to be working with the uh, multiplicative inverse of a second order matrix. So we're looking at inverse matrices and how to use them and how to find them for at least a 2 by 2, a second order matrix. All right. So let's go over to my notebook and let's start looking at what it means. One thing I want you to understand, one of the topics we always seem to have to cover is what is an inverse? So if I have something like, let's just use numbers to start. So if we use numbers, 2/3 has what as its inverse? Well, inverse, you also think of sometimes as reciprocal. What it is by definition, the inverse of 2/3 is whatever we would multiply 2/3 by to get 1. 1 is the identity element in the set of real numbers. So in this case, it would be 3/2 would be the inverse, right? And the reason that's the inverse is because when you multiply these out, you get 6/6, which is 1. 1 is our identity element. Anything we multiply is when I say identity element of real numbers, what I'm saying is if if I multiply anything by 1, it is still itself. It is still whatever it originally was. That's why it maintains its identity. All right, so it's the identity element. For matrices, we have that same thing. Matrices, some matrices have inverses, some don't. And we'll get into why and when that is important in a little bit. But first, what is an inverse matrix? Well, it is, again, it's a matrix that, say I have matrix A, that is some 3 by 3 matrix. And so A11, A12, A13, and so on. Less important what's in here than anything else. What I'm talking about is when we have this and we want to multiply it by an A inverse. If we said A inverse, we always note inverse as to the -1 power. There's a reason for that, but just know that's what we do. All right, so that's if I did A inverse and I have elements, and I'm just going to put dots because I don't want to take the time. I have some elements in here. If I do A, and this again is a 3 by 3 matrix, if I do A times A inverse, I would get 1 in a 3 by 3 matrix terms, which would be this. Because this, when we multiply this by anything, A times A inverse, if we multiply anything by its inverse, we would get this identity element. This is the identity element. This is 1 for matrices, for a 3 by 3 matrix. Because if I take this and multiply it by any matrix, what you'll find is, of course, we have a 3 by 3 matrix times a 3 by 3. We get a 3 by 3. If I do this row by this column, what happens? 1 times 2 puts 2 here, and all others are zeros. First row, second column puts a 1 here. First row, third column puts a 3 here. First row, second row, first column, 0, and then 1 times 4 puts a 4 there, and then a 5 and a 6. And for the same reason, only these would go in here. So it's kind of like multiplying by 1. It's the same idea in matrix terms, all right? It is, when I multiply this thing times any matrix, I get back that matrix. That's the identity. It's just like multiplying by 1. So what we want to be able to do is find a matrix inverse that would allow us to be able to do that, all right? And you'll see why, again, as we get to the second half of this section, all right? The second half of this lesson. All right, so how do we do this? How do we find the inverse? Well, the only one you guys are going to be responsible for, I just used a 3 by 3 as a demonstration, so it would be a little more obvious what was going on there. But only one we're going to be looking at is a second order matrix inverse. And it's the multiplicative inverse that we're talking about. All right, this is the one we're going to be able to find, or need to be able to find. All right, so how do we do that? Well, again, I'm going to start out with my good old matrix A. that is A11, A12, A21, A22. All right. This is my matrix. Notice I'm using the brackets again. We're not talking determinant, just a matrix. All right. Now, if I want A inverse for this, A inverse would be 1 over this, which is now what is that? That's the determinant of the original matrix. So 1 over the value of the determinant. This is where we get to use those determinants. Remember I said you'll see it in the next half? That's now. We're going to use this to find the inverse. And then we're going to multiply it by another matrix that is related to the original one in a very specific way. All right. What we're going to do with these values to get to this matrix, we're going to take these values, and I'm going to draw this in another color so you can see it. We're going to switch these two. All right. So we're going to put A22 here, and we're going to put A11 there. All right. Now, the other thing we're going to do is take the opposites of each of these. So we would have the opposite of A12 and the opposite of A21. They stay in their same position, but we take the opposite value. And when we multiply this out, this 1 over this number times each of these pieces, that would give us our inverse. Now, again, I know when you look at this theoretically like this, it's a little bit hard to sink in. Let's just look at a matrix. All right, I'm going to just use B just because we haven't. We keep calling everything A. So anyways, let's do this one. If I say -1, 4, 3, 2. This is our matrix, and I want to find B inverse. Well, B inverse is going to be 1 over the determinant of -1, 4, 3, 2 times the matrix we get by switching these two and taking the opposite of these two. So now, our B inverse matrix, this is going to be -2 minus 12. So that is a -14. So it'd be 1 over -14 times 2, -4, -3, -1. Now, if you're just asked to find the inverse, I want you to multiply this out. All right, so I want you to distribute this. Don't leave it this way. Fully simplify. So -1/14 times 2 is going to be a -2/14, which reduces to a -1 over 7. -1/14 times a -4 becomes positive, and it's 4 over 14, which is 2 over 7. On the bottom, negative times a negative make a positive, and that just stays 3 over 14. And negative times a negative makes a positive, and that is 1/14. So this would be my B inverse. Again, if they ask you to find just the inverse of any of these, this is what I want you to find. All right, fully simplified, putting the scalar multiple through it. The book will often give this as the answer. I want you to be able to give me the reduced fractions inside there. Okay, so that is our multiplicative inverse of that matrix B. And now, the big question on your mind, why do I need to know this? Well, we need to be able to solve a system of equations. Yes, we are back there. Remember we started the chapter solving systems of equations. So, oh, I wanted to say solve B, not All right, solve the system. We're going to want to do this with matrices. Okay, now, how do we do that? Well, let's look at a system. If I gave you 2x minus 3y equals -1, and I gave you -4x plus 5y equal to -18, we can solve this system using matrices, and that's going to be key here, using they'll actually, the way they'll tell you in the book is use a matrix. That looks ugly. I can't have that. All right, solve using a matrix equation. All right, those are the words they're going to use. And so I want you to know when they say that, what they want you to do, first step, they want you to rewrite the system using matrices. All right, how do we do that? We can rewrite this system entirely in matrix language. We do it this way. Let me get a different color so you can see it stands out. All right, so for this, if you just looked at these coefficients, I could make a 2 by 2 matrix out of the coefficients on that side. Now, we're going to always have to have a standard form where we have x and y on this side, our c, ax plus by, and a c on this side in order to do this. So we have this. This times this matrix recreates this side of that equation, because when I multiply this, if I do a 2 by 2 times a 2 by 1, the 2's match in the middle and it would become a 2 by 1 resultant. The resultant would be this row by this column. So this would be 2 times x plus a negative 3 times y. Isn't that 2x minus 3y? And the same way, first row, first column, or second row, first column, negative 4 times x is negative 4x, 5 times y is 5y. So this side recreates this side. Now, equal to, and then that one, I think is pretty obvious how it recreates this side, right? So this is another way of writing this exact system. This is the same thing. If I multiply this out, I get this, right? So what do we do from there? Well, the next step. All right, we've written the matrix equation. What I want to show you now is if I called this matrix A, and this is just my XY, I'm going to leave it just that and write it there. And this one I am going to call some matrix, let's just say, we can call it anything. I always call it the answer matrix, but let's just call it a letter. Let's call it C. All right, it's the one that has our answers, what the equation is equal to. But if we have this, we have an equal sign between them. Think about inverse quantities. If I had, and I'm going to do this over to the side, if I had 3x equals 6, I could multiply by the inverse of this. Multiplying by the inverse of 3 is 1/3. If I did that here, I would have to do it here, right? We always think of it as dividing by 3, but I could multiply by 1/3 technically. Multiply by the inverse. This would give me 1, my identity element, and it would leave x. On this side, it would give me my solution, right? Same idea here. If I take this and say I want to do A inverse times A, and I'm still multiplying by that, and then I do A inverse over here times C, I've kept the equality, right? I've followed my rules of equations. But this now becomes just the identity element. Remember, we talked about that in the beginning. That's the identity element for matrices. So this would be the identity element for this. When I multiply this out, I would get 1, 0, 0, 1. That's the identity element for a 2 by 2 matrix. That's what it would come out to be, which is just like multiplying by 1. So then this would stay xy. This side would be A inverse times that thing that was -1, -18 in this case. The answers are A inverse times C. So we would have this. So we want to do that here. In order to do that, we need to know what the inverse is of this. If we call this thing A, we need to know what A inverse is. So that is our next step. Our next step is find the inverse. And I'm just going to say find A inverse. So for our purposes, what we're going to do here, I need to get some more space, sorry. All right, what we're going to do is if we know this is A, then A inverse will equal 1 over the determinant of A, which is, this is A, times the matrix we get by switching these two and taking the opposite of these two. So let's find out what A inverse is. A inverse then is equal to, this is 10 minus 12, so -2. So it'd be 1 over -2 times 5, 3, 4, 2. Now in this case, I agree with the book. I like to leave it in this form. This is my A inverse. Because what I'm going to do now, remember, we said, if you remember back here, we said this side just becomes 1, or is just xy. The other side is A inverse times my answer. excuse me, my answer matrix. So now I can do A inverse times this thing. This is my A inverse. So that's our next step in this process, is going to be multiplying, find, I'll just say A inverse C. So for us, that's going to look like this. That's going to be A inverse is -1/2 times 5, 3, 4, 2. And you could distribute this if you want, but what I'm going to show you is we're going to be multiplying this by that matrix up there, -1, -18. And when we do that, it's easier to multiply these two. I'm going to leave the -1/2 where it is. This is a 2 by 2 times a 2 by 1. So these match, and we get a 2 by 1. So I'll have a 2 by 1. It'll be 2 rows, 1 column. So this would be my A11. So what is A11? Well, A11 is first row, first column. So 5 times -1 is -5, plus 3 times -18. That's a -54, I believe. So that would equal a -59, if I am correct there. All right. So we've got everything we need there. Let's go on to find A21. All right. Right. So I'm sorry, A12. I said A21. I knew something sounded wrong there. So this is -59. I'm sorry. I should put that in there. All right. And then we can go on and find A12. A12 is going to be first row, or A21. I did say it right the first time. I wondered why I got all messed up there. Sorry, guys. Once again, proving all of us can have problems some days. All right, so anyways, second row, first column, we'd multiply this out. 4 times -1 is -4, plus 2 times the -18, and that is -36, and we get a total of -40. So this would be -40, and now we can say that this is equal to a +59/2 and a +20. What does that mean? My answer would be to that system. Remember, is always a coordinate. This is my x, this is my y. So this would be 59/2, 20. That's the solution to that original system. And you need to be able to do this with matrix equations. All right, you need to be able to rewrite them. After you rewrite it, find the inverse of that coefficient matrix, the one that we called A here. Then multiply that inverse times the answer matrix, the one we called C, and eventually get an answer that is a coordinate, just like we thought in the beginning when we did all the way back in 1-3. We solved systems and we found that if they have a solution, a single solution, it's going to be coordinates. Well, that's the coordinate we get there. So that is what we're going to be doing for the second part of this section 2.5. And you'll have your assignment. We'll go over tomorrow. Have a wonderful day as always, and I will see you back in class.